Hey guys, hello from Deviant Nestor. This is the platform where you will get information about mechanical engineering, humanities, and Vedic language. Our very first, our very first topic is from mechanical engineering field about how to select air cleaner for a particular engine. So let's start with the basic idea of engine and its peripheral. Engine peripheral consists of air intake system, cooling system and exhaust system or exhaust after treatment. In this video we will focus on air intake system. So this is a layout which shows how air intake how engine works, which consists of air intake. This one is air intake system, this one is cooling system, and this one is after treatment or exhaust after treatment system. In this particular slide I have mentioned the turbocharger. Engine may be turbocharged or naturally aspirated. It depends on the engine manufacturer or requirement of the engine, how much power or how much HP it is about. So let's begin with how to select the air intake system. Now when there is a turbocharger and when there is no turbocharger, when there is a turbocharger, that is air intake system without a turbocharger, in that situation ambient air goes to air intake. It purifies air. Ambient air or impure air goes inside the air intake system, air cleaner. It purifies the air and clean air goes to engine. When engine consists of turbocharger or it is not naturally aspirated or turbocharged engine, then air cleaner, then impure air or ambient air goes to air cleaner. It gets purified. There is a pressure drop which is most important and very important for the engine, which we will discuss later in next slides. So this air gets purified and it goes to turbocharger. Now turbocharger is in fact very awesome invention for the engineers. Why it is very important I will explain you later. That a pure air or purified air goes to turbocharger, it get compressed there, and as we know that compressed, when we compress anything or air, and its temperature and pressure will rise. So and there is a need to cool down the air, but keeping in mind that pressure must not be decreased too much. That is, we need to take care that pressure drop should be minimum as possible, minimum as much as possible. So it goes to intercooler, and this thing depends on the shape of the intercooler. How pressure minimizing pressure drop depends on the shape of the intercooler, that we will discuss later. That compressed air goes to intercooler, it gets cooled, and then it goes to the engine. Now air intake system or air cleaner is having two type. First one is having dry and second one is having a wet type. In dry type, as you can see in slide, that in dry type of air cleaner, air, this one is air inlet, air passes, air comes when there is a suction, from the engine, there is a suction pressure, and air sucks from the inside, from this port, and it gets clean from the air cleaner air cleaner, and you can see there is a dust accumulator, and it is called as unloading valve, which due to mass of the air or heavy mass of the air, it gets accumulated there, and we can eject dust from this point. This is the dry type of air cleaner. In wet type of air cleaner, in sump there is a liquid. What liquid does, it catches the impurities or dust particles, and it's accumulated there. So we need to remove that oil at a particular interval of time. In this lecture or in this video, we will learn how we decide to um, how we will select air intake system, or what is the procedure to selecting of air intake system. So I have engine specifications, in which we have number of cylinder is 4. It is direct ignition, direct injection system, and compression ratio is 18.3, displacement is 3000, and its max power at 22,000 rpm 2200 rpm is 44 kilowatt, which is important in our calculation. And all these datas are given. Its high idle is 2300 plus minus 10, and low idle is 900 plus minus 10. Those who are engineers who can correlate what is the high idle and low idle. And the most important thing is air intake, air flow restrictions, that is restriction offered by the air intake system. So when we if someone asks us what would be the air cleaner size, someone says 5 inches, 6 inches, 7 inches, 8 inches, then how we will come on the conclusion that what type of and what inches of air cleaner required. So to get all these questions, first we have to find the volumetric flow rate of the air cleaner. In automotive industry, it is called as the cubic feet per minute, a cubic feet, CFM, cubic feet per minute, and it is calculated, it depends on that CFM depends on the swept volume which engine manufacturer will provide you. This one is displacement, swept volume, speed, this speed is maximum speed, V is the volumetric efficiency, PF is the pulsation factor, and CF is the cycle factor. So we will discuss what is swept volume, speed, VE, PF and CF, and how it is taken. Kindly note that in swept volume, unit of swept volume is in cubic inches, and the speed is high idle RPM, not rated RPM, not low idle RPM, not max torque RPM. It is the maximum RPM, that is high idle RPM. Now, how to select the volumetric efficiency and pulsation factor and cycle factor? So there are some basic terminology which we should consider while taking values of volumetric efficiency, pulsation factor and CF. Here I have mentioned all these things. While using volumetric efficiency, we have to keep in mind that whether engine is new or not. If engine is new design, then we will take as volumetric efficiency greater than 2. Now keep in mind that since it is efficiency, but volumetric efficiency can be more than 1. So don't get hesitated that volumetric efficiency can't be less than more than 1. It may be more than 1 or it may be less than 1. Since we have learned all our in all our graduation or btech that efficiency can't be less than can't be more than 1, but it is a volumetric efficiency, and I do consider that you know about very well about the volumetric efficiency. Now volumetric efficiency will be taken as 1.3 to 1.8 for 4-stroke engine with turbocharger, and volumetric efficiency will be taken, we will take volumetric efficiency 0.85. Many people take it 0.9, 0.95 for 4-stroke engine that is naturally aspirated. In our situation engine is naturally aspirated. VE will be taken as 1.4 for 2-stroke cycle engine in the root compressor, that is not important for us right now, and VE will be taken as volumetric efficiency will be taken as 1.9 for 2-stroke engine with turbocharger. So in this situation we will take volumetric efficiency equal to 0.85 for 4-stroke engine that is naturally aspirated. Pulsation factor, this pulsation factor is applies only engine which is both naturally aspirated and having 3 cylinder or less. If you have 4-cylinder engine, then you will use pulsation factor as 1, otherwise we will consider pulsation factor equal to 2 to 2.1 if only there is 1 cylinder. Pulsation factor will be taken as 1.4 to 1 for 2 cylinder, and pulsation factor equal will be taken as 1.3 for 3 cylinder. But in our situation number of cylinders are 4, so pulsation factor will be taken as 1. And what is cycle factor? The cycle factor will be taken as 2 for 4-stroke engine and 1 for 2-stroke engine, but in our situation it is 4-stroke diesel engine, that is why we will take as cycle factor as 2. So if I will put all these value, when I will consider displacement cc cubic centimeter is 3000, and it will when I will convert it in cubic inches, it will become 183. High idle is 2300 plus minus 10, so we will take it, you can take it 2310 or 2300 or 2290, and volumetric efficiency will be taken as 0.85 as I have mentioned earlier, and pulsation factor will be 1728 into CF will be 2 because it is 4-stroke engine. It will give us cubic feet per minute is 103.5. Cubic feet per minute is actually, if I consider cubic feet per minute, it is a volumetric efficiency. Feet is a unit of length, and per minute means time. So cubic length per minute gives the volumetric efficiency, and if we will convert it in meter cube per minute, it will give us 2.93 meter cube per minute. It means this engine requires 2.93 meter cube of air every minute. This engine requires 2.93. It means ki in selection of air intake or air cleaner, we got first value, that is volumetric flow rate, and it is 2.93 meter cube per minute. So our next target will be what will be the initial restriction. As I have earlier said that when air passes through the air cleaner, there is a pressure drop. So how much pressure will be dropped, and pressure drop is very important for any engineers. For engineers, two things are very important. First thing is space constraint, and second thing is pressure drop. Every time when we design, we need to keep in mind there must be minimum pressure drop as possible, and second thing is how to accommodate that thing in a constrained space. So Our next aim is to find what is the air restriction offered by this air cleaner when the volumetric flow rate is 2.93 meter cube per minute, and what would be the initial restriction offered by the air cleaner. So let's begin here. When you will come to know all these things, you will have there is a restriction and airflow graph which shows that as we increases the airflow, that is CFM, or in upper side it is written as meter cube per minute. When we increases the airflow or volumetric airflow, then there is an increment in restriction, and restriction is given in inches of water, that is it is given in height h, and we know that pressure drop or pressure is equal to h rho g, p equal to h rho g. H is the height, in this situation h inches of water, that is 4 inch, 5 inch, 7 inch, that we can convert in meter, mm, and whatever suitable to you, inches of water. So we will get restriction and airflow. As we can see from this graph, as we increases the airflow, restriction also increases. Although this is not a linear graph, somehow it is parabolic. And second one is final restriction. Final restriction generally taken as 25 inches of water, that is 63 millibar. It is approximately 63 millibar. So what we have to do, that we will draw a vertical line of our having CFM. In our situation, the CFM is 103 or 2.93 meter cube per minute. So here you can see that I have drawn a vertical line, this vertical line at 2.93 or CFM 103.5 something. Now this line will cut at 2 points. First it will cut at 2 points, that is at restriction and final restriction. When it will cut at first point, that is restriction offered by the air cleaner, it will from there we have to draw a horizontal line, so that we can find that what is the initial restriction offered by the air cleaner. Now what is initial restriction? Initial restriction is, as I have told you earlier, when there is a flow of air in air cleaner, it consists of air cleaning system which is made of paper element, and it restricts air to flow. When there is restriction, it restricts air, that it means ki there is a suction power of engine, and external thing which is engine, external thing which is air cleaner, which is restricting our flow. So we need to keep in mind that air restriction should be minimum as much as possible. So in this situation we found that initial air restriction is 4.9 something or 5, approximately 5 inches of water. That is, if we calculate the value of in pressure, then we can find that it would be h rho g. H means 5 inches. Inches, if you convert inches in mm, that it would become 5 or 4.9 into 25.4 into rho, density of what? Air, water. Density of water would be 1000, and g would be the 9.81. It will give you the pressure drop. Second thing is, what would be the dust capacity of that air cleaner? That is most important thing. At what interval and after how much accumulation of dust we should change the air cleaner. So you will get that data from this final restriction, which is written as 25 inches of water. Now we have to draw a horizontal line from this 25 inches of water, and it will give us 3.4 kg. It means ki what we have selected, the air cleaner, it has or it must have a initial restriction of 4.8 or 4.9 inches of water, and it will be able to accumulate a dust of 3.4 kg of dust. So it was all how to select the air intake system, air cleaner. Understanding of air cleaning system is important, but calculating of how much what is the volumetric flow rate, what is the initial restriction, and what is the dust capacity is important for the engineers to select the air intake system. So this is all about the air cleaning system. Please give your feedback, suggestions about this video, so that we can improve as per your suggestion, and please don't forget to like and subscribe. Thanks for watching this video. Having happy learning from Deviant Nestor. See you in next video. Thank you.